Guys, good morning. My name's Joey Baker. I'm with SBS. I get to focus on implementing our substation design suite applications at utilities and engineering firms that support the utilities. You know, as I was preparing for this presentation, I was kind of struggling a bit with who to speak to. Envisioning the audience. So I've taking a stab here trying to really prepare hopefully a message that'll resonate well enough with you guys that you'll feel comfortable going back to your office and talking to your substation folks and engaging with them and talking with them about the AUD product that we've expanded for substation applications, which we'll spend most of our time talking about this morning. So hopefully this message will work out well and resonate with you. Again, to reiterate what Ryan said, would certainly welcome all the questions you can come up with that would make this presentation a lot more impactful for everybody. So thank you. So before we really get into a deeper discussion about the products, I thought I'd take a couple of minutes to mention some of the other really important items we've been working on the last 6 to 9 months or so. Sean and Carly in our support group, they have built what's honestly, in my opinion, a really world-class support portal that provides our customers with a lot more self-management capabilities. So if you guys haven't had a chance to interact with that, I certainly welcome you to do that. The portal that we've got there for support is just really well done, and a big shout out to Sean and Carly for putting that together. Also, over the last, 6, 9, 12 months, Ryan and the entire marketing team have really been focused on improving our customer experience, and a big customer-facing way that we're doing that is with our learning portal. So we have a brand new learning portal that houses all of our learning content. So I think as here in the very near future, you'll get more and more exposure to that. And so would certainly invite you to go check out our learning content on our learning portal. Along with any of those items, would certainly welcome your feedback. So I think a theme hopefully you'll pick up on in this presentation is that, quite honestly, most often we don't really have to guess at what's really important to our customers. I think that we have really strong customer relationships, and we work hard to really take time to listen, hopefully taking time to understand and to pivot, when we need to meet our customers' most pressing needs. Yeah, I've got this slide here. I'm not going to really go through this slide, but it's something that's kind of universal as we've been working with customers over the years. We've implemented our SDS technology at numerous utilities throughout North America, really around the world. To each utility, it seems like the aspiration is essentially the same. The utility wants to achieve improved design efficiency while at the same time reducing design errors, and all at the same time while increasing the throughput, increasing the production speed, right? So I borrowed this particular slide from some of the some work that a customer did to articulate internally the benefits that they expected to achieve once they implemented the SDS application. As you can see here, this particular customer anticipated achieving benefits, from deployment of their SDS, significant benefits from the deployment of their SDS system. Really using this as a single specific example, but the justification figures that we see, when we go and work with various utilities are typically in this realm. Significant overall improvements, all really leading to this idea of making the capital investments returnable sooner, right? So this is a big driver that we see kind of universally across all the different utilities that we have the opportunity to work with. And based on the benefits that we're able to see in the previous slide, at SBS, I mean, I think it's a fair question to really ask it. If utilities are able to justify implementing the SDS technology, over the years, then what was the real driver behind developing the SDS physical for AutoCAD application? And I think, really over the years, the more our customers got kind of beyond the sexiness of the 3D modeling aspects, I think what we started to feel was a lot of questions kind of beyond the tool type questions. And what I mean by that is, questions that typically involve complexities around, related to deploying Inventor to large work groups and integrating Inventor designs with other systems. Questions that are really above and beyond just the tool aspect itself. In several cases, our customers realized the results they were able to achieve early on in kind of a pilot project or in the lab type location. The pilot projects, they just were not able to sustain those types of achievements when deployed to the masses, and that the promise of kind of the BIM for utilities is quite different from what we're seeing. That promise of BIM for utilities is really different than what we're seeing as a BIM, for construction companies. And I think that that's been a big discovery in the utilities that we've been working with the last several years. So what I think we've learned on the substation side is that the Inventor-based application, really did offer superior precision, right? Especially when you compare, those workflows, those 3D design workflows compared to 2D drafting and 2D design workflows. But in reality, the solution, in a sense, was off the mark a bit, because we really weren't, with the Inventor-based application, we really weren't able to address the utility's vital first needs. And what we're seeing, and I think on the distribution side, you guys have seen this for a long time, but that vital first need is really kind of a data-centric workflow. So we're, on the Inventor, with the Inventor product, we can really handle and do really well. We have a fantastic product for doing substation design. When we need to integrate that into a more of a enterprise system, that particular product isn't able to support as well as some of our other products, the overall utility data-centric workflow. So I'd really like to take just a couple of minutes to talk about, BIM for utilities and what we're seeing there. I think in the early days, we would see a lot of emphasis put on BIM, 4D, 5D, 6D. And usually, we're borrowing those concepts from other industries, and that typically meant being able to connect, 3D design models with other applications that supported things like animated construction or animated scheduling. You guys have seen those those kinds of demos in the past. I think what we're seeing more and more of today really is that first level importance at a utility being placed on eliminating data silos, eliminating data redundancy, and genuinely building platforms from the ground up that are based on the single source of truth doctrine. So that's such a vital concept within utilities. This may sound, quite honestly, a bit obvious to this audience, the distribution, engineering, and design and workflow audience here, but I think in the substation side, we're really I think we're catching up a bit to the distribution world and recognizing that the fundamental benefits of BIM for utilities is in connecting design outputs, with the enterprise systems that support asset management and work management. Fundamentally, I think that we see the SDS applications as being a fundamental element in the utilities asset management and work order management technology suite. So it's a bit of a different perspective than I think that we had, 10, 8, 5 years ago, where we were primarily focused on kind of that traditional BIM view, getting customers to 4D, 5D, 6D, kind of that traditional space. I think that the substation application and the customer base is really maturing along the lines of we need to first and foremost be able to connect our data from an asset and work management type of perspective. And once we're able to really understand that our design tools are essentially the cornerstone of any utilities asset management strategy, it was really fairly easy for us to see that expanding the capabilities of AUD to satisfy substation specific design requirements was really the best route in order for us to solve some of the most pressing challenges that we were hearing from our utility customers, those utilities that were looking to integrate substation assets into their enterprise systems. For me, quite honestly, kind of being an outside observer for a long time of AUD, it was, really very hard not to be kind of super jealous of all the kind of the capability that AUD offered. On the substation side, we simply did not have a robust design assist capability that design assist capability that is really native to AUD. You guys understand the rules engine and and all the other applications that are built in inherently to AUD that are there to assist that designer. We just simply did not have those kinds of capabilities in the existing SDS products. AUD also offered out of the box a number of solutions to some of our customers' most frequent challenges, especially the ability to reduce the change management hurdles that we were starting to see that were affiliated with deploying Inventor to large groups of users. Even though I absolutely love the capability provided by the AUD rules engine and all the other capabilities, and could see how this functionality could really truly be a game changer to the substation engineering and design community. For the last, I'd say a couple of years ago, I still had a fairly healthy dose of skepticism. How are we really going to be able to address kind of the level of precision requirements that our substation customers expected from their design tools? So I want to spend just a couple of minutes kind of talking through some of the things that we've worked on over the last 12 or 18 months to really address that first and foremost fundamental requirement that was surfacing on the substation side. Through briefings with our both our prospective customers and our existing customers, we've really had the opportunity to gain a much deeper understanding of what is most critical for utility organizations, especially those that are really given serious thought in implementing an intelligent substation design solution within their organization. From really, I think from the outset, one of the imperatives that we have had in place when we set out to build the SDS Physical for AutoCAD application was that all the functionality that existed in the Inventor-based application would carry over to the Physical for AutoCAD application. So there would not be any give back from a tool functionality perspective. We really use the Physical for Inventor application to establish a baseline for constructing the Physical for AutoCAD application. The other imperative for us was recognizing early on that having two applications, our Physical for AutoCAD application and our protection and control module, built on top of the same AutoCAD foundation, really did allow us or present us an opportunity to close what's really been a fairly large gap in the industry between different work groups within utilities, between physical designers and protection and control designers. So we'll show you a little bit of this here in just a few minutes. But being able to address one of those fundamental needs from the industry by having a different tools on a common platform has really enabled us to, I think, close the gap on one of the industry's most pressing needs. And of course, with any decision, there really are trade-offs. And as this slide shows, P4A will benefit those utility organizations that are standardized, that are standards-based. It'll benefit those organizations that are really looking to have a genuine, intelligently connected ecosystem, and that single source of truth that we talked about a minute ago, reducing data silos. So those types of organizations will benefit from the P4A application. Our inventor-based SDS application remains a world-class solution, and it's primarily for organizations that really require bespoke or one-off type designs, and that are not looking to integrate their design outputs into a larger enterprise ecosystem. So, that tool remains a world-class substation design tool, and it's there to serve a different niche than the physical for AutoCAD application. I'm going to show you a video here, and I'm going to talk over the video. What I really want to do here is just kind of let you envision what P4A. This video is getting a little bit old now. We've had this video, quite honestly, from the very outset of constructing physical for AutoCAD, but I like showing this video because we really used this to establish the benchmark for us of what physical for AutoCAD needed to be, what it needed to be able to handle, what it needed, the functionality it needed to be able to provide at a baseline level. And so, for us, this meant we needed to be able to address all the areas of substation design, including the above grade, below grade, the indoor elements of substations. As mentioned, the application would not only need to perform all the functionality as the existing inventor module, but also assume all the capabilities of the AUD distribution module, which is quite extensive, as you guys already know. As I'll show you in just a couple of minutes, when we transition to the product demo, you'll see that we have I think we've definitely hit the mark on what we set out to do. Also, as you guys are very familiar with, product development is a continuous improvement process. So we're very proud of where we are today with the product, but are also very excited about the future developments, and quite honestly, very much excited about receiving feedback from our customers on where the product should go next. Last thing I want to show you, let me make sure here. Yeah, this is right. Okay. So the last thing I want to show you here, I'm really excited about this. Let me turn him off. I do have it on kind of accelerated speed here because we don't need to show all of this video. But the main thing I want to show you here is that, again, as I mentioned before, that one of the imperatives that we established from the outset was reducing the gaps that existed between different work groups within the utility, especially those gaps between primary and secondary design groups. So your physical designers and your P&C designers. In this video right here, we're showcasing the ability to associate, the primary representations of elements like a circuit breaker, like we're showing here, and the corresponding secondary representations. Having the primary and the secondary design applications on the same fundamental platform, being AutoCAD, we think opens up opportunities for us that simply did not exist before. We're really excited about this. We're in the early stages of collecting use cases and user stories and requirements. So if you have any colleagues that you think could benefit from this functionality that we're showing here, how to be able to associate, 3-line representations or 1-line representations with physical representations of the same devices, and we would encourage you to ask them to reach out to us. We're actively soliciting, those use cases, from the industry so that we can have a better idea of what challenges this kind of capability could resolve or diminish within the utility workspace. So I hope that that's kind of been helpful. That's a real quick overview. We're going to get into the tool here. Before we get into the demo and open up the application, I just want to say I appreciate you letting me talk about our P4A application this morning. I hope, as you can tell, we're really excited about the product, where it is today, and the next wave of items that are in the development pipeline. Dave, Sarah, Marty, and all of their teams, they have really tackled a lot of the fundamental hard items to make this possible, to get this product to where it is today. It wasn't all that long ago that there were some big fundamental things that we just didn't know if we'd be able to do that would be satisfactory in the substation design world. Well, I'm just tickled to be able to say that we have it's Dave, Sarah, and Marty, and all of those guys. They have knocked every one of those out. So just a huge shout out and an appreciation for them. And also, while I've got the mic, I'd like to express again a gratitude to everybody on the AUD team. They've had to kind of drag substation folks along and get us up to speed on AUD lingo and terminology and fundamentals. So they've been really patient with us, and just a big thank you to all of those guys. And so thanks again for letting me present to you this morning.
Appreciate everybody sitting in. I was asked to just show a couple of the things that we've been working on and give you some real examples of substations and some workflows and things like that we've been playing with here with the new P4A. So you will probably see this screen quite a bit. This is actually our training project. So along with all the development that's gone into creating P4A, we've also rewritten a whole set of training, or written an entire set of training that goes along with it. And this is the substation bay that you produce as part of that training. So users will actually go through and be given, exercises and instruction and help in creating what you're seeing here. So this is probably the most common one you'll see, all the way from the lines coming in off the transmission through some switches and breakers to some underground power that goes into a internal house with a switch inside the house. So let me switch over to wireframe, and you kind of see the switch here inside the house. So good representation of a lot of the different pieces we've been shooting for with P4A, a lot of the things that we've been wanting to be able to handle and do. I purposely kind of removed one of these conductors because one of the most common questions is how do I place things in P4A? Can you show me how to place particularly linear objects? So very similar to AUD, if anyone has ever seen an AUD demonstration. Up at the top are all of your placement commands, kind of grouped, right? Plant equipment, structural building, configurable, but out of the box, it'll be grouped something similar. You pick what conductor you want, click your starting point, and then you hover, right? So one of the cool things you're getting with P4A is all of that connectivity, the rich connectivity type stuff that AUD supports. So we kind of train folks to look for these little yellow symbols and this little pop-up with the knuckles that click together. So I'm going to click just to start my placement, and then I go to where I want to end my placement and just look for that same yellow, and then click again. Whenever I hit enter, AUD goes ahead and runs the calculations. P4A AUD runs the calculations based on sag percent and tensions and the distance it goes before it sags and the distance it goes before it comes into there, as well as having control over whether or not it's treated as a straight line or as a spline or a catenary. You can kind of swap back and forth and adjust all these things on the fly, and it will just resag. So you have a ton of control over forcing it to be linear for stuff like rigid bus versus forcing it to follow catenaries and splines and things like that for non-rigid conductors. So lots and lots of control over those. I know that's a point that a lot of folks wanted to be aware of. But as you can see, there is an object, right? There is a feature that has been placed. And as I hover, it goes over and you can see every one of the features that I placed that is related to a feature with attributes and connectivity as well as material. So at any point in time, I can select graphically this object and then say, what material belongs to that object, and it will jump to that as well. So this idea of having, graphical and material and attribute and connectivity and all that kind of stuff is we think critical going forward. Lots and lots of folks are asking us about the support for GIS implementations going forward, and can we exchange information back and forth with GIS? And this is a huge part of what you have to support to be able to do that in the future. So lots of cool workflows coming out of this. We're still exploring. It's kind of in a limited release right now with several of our partners. We're working together to work through workflows and make sure it supports all the things that we need to do substation design. Yeah, okay, so this is our base training model, pretty decent size, at least for right now. We haven't seen anything in terms of performance problems so far. So for those of you that are worried if we're really, starting to stretch AUD, AutoCAD's capabilities, so far we've been okay. Something coming up on the horizon for those of you that are into kind of the technical side of things. This is AutoCAD 2022, AutoCAD Map 2022, and they introduced a graphical preview engine that you could enable. And starting in 2022 going forward, Autodesk is working to offload graphics rendering directly to your card. So that's something that hasn't been available in the past. And you can tell even here on my laptop, right, that there's zero lag in this zooming in and out. So the graphical preview, between being able to use graphical preview on a lot of the 3D objects and being able to switch into wireframe if I really want to dig into some of the details, I've been pretty successful at seeing very little, if any, performance degradation because of graphics, which, as you know, as you get into 3D is sometimes a concern for AutoCAD. But so far, with everyone we've been working with, we have received no reports of that. So just wanted to make sure everybody was okay with that. I'm going to switch over to another model here just to give you another example. Kind of talk through this a little bit because there's some really cool connector work that they've done here. So this one, if you kind of look at one of these connectors here, and I'm in realistic mode, so you'll see a little bit slower performance, but still okay. So here, as I hover down through all of these different turnbuckles and shackles and suspension insulators, you can see that every piece can be individually modeled. So this particular client, does some very complicated kind of stuff with their insulators and shackles and turnbuckles, and wanted to have control over all of them. So they actually specify them as individual components and can link them all together. Leads to some really cool stuff, like being able to do like these nice jumper loops across on insulators. Yeah, and this is a little more of a, less of a training scenario and more of a realistic kind of, drop down here where they're coming in and dropping from the middle of conductors and down into other switches and whatnot. So a little more realistic layout of some of the complexities that you could have inside of a substation. Took took about 2 months, a little over 2 months. These were all these blocks, all these parts were configured by the client, and it took them about 2 months to go from scratch to being able to generate all these components themselves. And then once they created all their parts, took about 2 hours, 2.5 hours to lay this out. So, you know, fully connected, fully attributed materials, you know, kind of GIS ready layout, full 3D. You know, it took about 2.5 hours. So similar, if not a little better, performance gains that we were seeing with Inventor, you know, from someone that really could fly in Inventor. But in addition, also has all the connectivity and attribution and is GIS kind of enabled, right? So lots of bonuses there. Continuing on with another example here. The other side of what you will need to go into GIS is geolocation, right? So GIS is not only feature, attribute, connectivity, that sort of stuff, but it also is in the correct place on the face of the earth. And this is an example of leveraging that. You know, AUD and therefore P4A, physical for AutoCAD, is based on Map3D, Autodesk Map3D product. And that product is inherently aware of coordinate systems and geolocations and can also support civil operations, right, with the civil object enabler. So what you're seeing here is a brownfield substation. This gray underneath, the mat underneath, is actually a civil surface. So that civil surface is hovering up in the air. I go and show you the properties on it. You can see that it's an external reference. Let's see if I have it here. So, I don't want to show you. Oh, here it is. 420 meters is where it's at. So it's about 400 meters above sea level. This is then geolocated on top of that civil surface. And the map was pulled directly from Bing Maps through Autodesk's you know, online map display. So what you're seeing here is a civil surface with correct Z elevation heights, a geographically located Bing map in the correct coordinate system, and then overlaid on top of it, we took the top-down view of the substation and aligned it directly on top of the map. And then we took the side section view and flipped it 90 degrees so that it was standing on its side down the center line of the bay that it represented. So we're taking brownfield level drawings, the top here, and placing it down, the side, flipping it sideways as references. And then you can go in and edit that external reference, you know, by the edit XREF in place or just opening it and managing it that way. But you can delete out pieces that you're going to replace and then use the combination of the side and the top to replace individual components in the brownfield. Like for instance, in this case, I actually put P4A lightning masts in the correct location on the brownfield based off of what the top and the side view were telling me. So I know that that is the correct location of where they're supposed to be. Now the cool part of kind of blending these brownfield and top-down kind of views and intermixing the P4A is that you can then go back and reference those into, you know, construction drawings and construction prints like you're used to producing. So this is that Yarn Leah North drawing X-referenced. So it's X-referenced in here. This is the flat view and the civil drawing and the, you know, the map kind of on its flat. And then this is the one that was flipped on its side. And then you can see in here that these are actually the lightning masts, right, that we replaced. So you're able to kind of produce these flat 2D construction prints that folks are used to seeing while leveraging the brownfield and the 3D and you know, all the new fancy stuff that comes into the picture with P4A, right? So just wanted to kind of run through a couple different examples of you know, something where we know how long it took to put this together, or something where we had some brownfield work, so you can kind of start thinking about how some of your brownfield processes might apply. Something in our training project to give you an example of you know, the kind of training projects we're putting together, helping people work through. And I guess, Joey, we only have about 8 more minutes or so, so I'm gonna stop talking for a little bit and see if there's any questions or anything that we need to show. Anybody have anything in particular they'd like to see or talk through? Let's see.
There's no comments or questions so far, Jim.
Okay, thanks, man. Anything else you would like me to show, Joey?
Just keep tap dancing.
Nice.
Yeah, Jim, if you don't mind just kind of zooming in to some of the underground, I think that that's just really powerful features here within that we're able to achieve within P4A. This is capability that we didn't really have cracked all that well in the inventor-based application. What I think our substation engineering community will really grow to appreciate about this is, you know, adding these conduits with the conductors that are inside the conduits. We're adding near zero additional model density to be able to do this. So this goes back to the kind of the concept that Jim was talking about with the fully connected electrical topology network. You know, we can see a use case here where you actually have a topology network that goes, you know, not only from the transmission through the substation, but we can carry that topology all the way through the secondary system as well. And it's what Jim's showing here is entering into the control building, whether that's to a switchgear or whether that's to individual AC or DC panels.
So Jerry, we got some questions now.
Yeah, good, perfect.
What's the first step going from the 2D DEM designs to 3D models?
First step. Well, number one is going to be a mindset, right? You know, and I think we would say, let's get into training. Let us expose the P4A application to you. I think what Jim showed from, you know, it's kind of a case study here. Working with a particular customer, as he was showing before, we were able to introduce them to the product, take them through training. You know, within a couple of months, they're over. You know, they're kind of over the hump. They've created content. They're placing content within the physical for AutoCAD application. I think one thing that's kind of a different transition that we're seeing a little bit, if folks are you know, experienced with 3D. And one of the things that we need to keep reminding the designers about is when we talk about a model, any of these models here in P4A that Jim's showing, we're really talking about an entity that has it's a two-sided coin. There's the 3D or graphical representation of that model. But what's really driving the intelligence and the behavior that you want to extract from the system is the data model that is affiliated with this 3D graphical representation. So building in all of the data that supports that 3D graphical representation, that's where we're really able to get the functionality out of P4A that drives all of these rules. You know, you want to click on the not the validation results tab, and we should see, you know, all of these amazing rules that say, hey man, you did something wrong, right? This is the power to me of P4A, is that we have this fantastic rules engine. The developers may not like for me to say it this way, but I don't know of any limitations on this, right? So if you can think of the mistakes that have been made on past projects, if you can think about what generated those, we can likely have the attributes built into the models that would support validating your design. It could be anything from, ampacity checks to, physical clearance type checks. So, and anything and everything in between. So I hope that's kind of a close answer to that. We would say get into training and let us get you to just working with the tool would be the first step.
So the next question was, what should be tackled first for maximum momentum? And kind of what I heard, Joey, and this is correct me if I go wrong here, is the first thing is get your models built. That's one of the big, huge advantages of going into the AUD engine for AutoCAD is the flexibility that it gets. So, if you don't try and do not only the rules validation, but all the auto corrections, just find out the rules validations first, and then you can build out those rules as you go along.
Yeah, absolutely. Yeah.
Yeah, same with the
totally. Yeah, totally love kind of the piecemeal approach here. It may not be the right way to say it, but you don't have to, build your entire universe before you can put this application to real productive benefit. This is a kind of an expandable capability. And so I love that about P4A is that we can just get in, we can have some models. Jim, drop down, go back to the substation tab and just drop down on the major equipment, plant equipment, any of that. And so we can continue to add content here, right? So you don't have to have every voltage deployed on day one. You don't have to even have every model. And so I think you can, just continue and have that as part of your implementation strategy, that you're going to continue its self-building, content library. I tell you one, from a substation perspective, this is really one of the most powerful features that I think is kind of embedded into P4A. What I love about this is if I'm a utility, okay, then my standards and only my standards are embedded directly into the application here. So when I deploy, this tool out to my contract engineering firms or to my brand newest designer that just, came to my staff last month, the tool itself becomes a quality control aspect, right? Because I have rules. The only equipment that is deployable on a project are items that have been approved for use within my organization. So I love that kind of lanyard free benefit that you get with P4A, is that you have your standards embedded directly into the application that your designers and your contract designers are using to do work on your behalf. So I just think that that's one of the most fundamental benefits of P4A.
So our standard approach is pick a style of substation. I don't know what the right term is. It's a voltage, a certain voltage, build out that substation as a strong pilot.
Yeah.
At that point, you would have all your models in there. So be able to change a transformer to the next model. We can do that through configuration. But get that core system down and then build it out from there.
Yeah. Yeah, and build out your understanding of how it really works. And, that's right, Pat. That's great.
Hey, this is Dennis. I would just like to add one thing too. If you were starting to work with 3D substation design 5 years ago, that starting point that you want to take on would be quite a bit different from how it is now. So a lot of organizations spent a lot of time building out all those 3D models. And we've actually done quite a bit. We aren't sharing it here because this isn't like an intense substation conference, but we've built a content library so you can go access a lot of that content. We've also developed over 30 configurators now, so you can also parametrically enter contents. So as you think about getting your 3D content in place, it actually can go pretty quick. As Jim mentioned, that one example, it took a couple of months. That used to be a couple of years not too long ago. So also keep that in mind. And that's an area where Joey and his team can give you quite a bit of guidance on how to get started.
Yes, and I guess just the last thing I would say is, for those that have AUD today and are seeing this in the substation, it is a substation implementation from the physical for AutoCAD is much simpler than an AUD configuration. You don't have pole tops that can go at 10,000 angles off a pole and joint use hanging on it and everything else. I mean, a rigid bar is pretty much going to be straight upstream, downstream in a bay. So being IEEE based, the configuration is far less, it's more of equipment and bill of material generation configuration versus all the complex engineering standards that go into a distribution configuration.
Good. Thanks, Jim. And appreciate it, guys. Thanks for allowing us to join in.